It's your friendly math tutor, Miss C, here to write the equation of a quadratic equation that passes through these 3 points. You might be thinking, why do I need 3 points? Well, the general rule when you're writing the equation of any sort of function is that you need one more point than the degree of the function. So what I mean by that is we know general form of a quadratic looks like y equals ax squared plus bx plus c. The degree of this is the highest exponent. In this case, it's 2. So because the highest degree is 2, we need 3 coordinates. When you write the equation of a line, the highest degree in y equals mx plus b is 1. That's why you need 2 points. So if you had an equation that was a 5th degree function, you would need 6 points to write the equation. Hopefully you never have to do that because that is a lot of work. So let's go ahead and think about a few more things before we get started writing this equation or figuring out this equation. So you're going to notice there are 3 variables that are not x and y. We have a, b, and c. A is often called the leading coefficient, and c is the y-intercept. We also have y on the left side, but for what we're going to do, I'm actually going to move it over to the right side, and I will explain why in just a second. The other thing that I want us to remember is that graphs of quadratic functions look like either right side up U's, so something like this, or upside down U's, and they can either be really narrow or they can be really wide, or they can just be normal. So I'm looking at the 3 points that I've plotted. They're color coded based on the points. I'm thinking just based on their pattern that we're probably dealing with an upside down U type of graph, which means our A is negative. We will see if that is correct. So let's go ahead and get started getting ready to find our variables so we can write this equation. And we are going to have 3 equations. So I'm going to go ahead and write a bracket. And I'm going to use my first equation. So I'm going to write my x values. Everywhere I see x in the equation, I'm going to substitute in -1. And everywhere I see y, I'm going to substitute -6. So in for x goes -1. And I'm going to write that first. And then I'm going to write a here plus there is an x here. And then b is just hanging out because remember, we're trying to find a, b, and c, so they stay a, b, and c. And then my y value is -6. So this first equation is done. All right, my second equation, I have x equaling -4 and y equaling -27. So I'm going to essentially do the same thing. Everywhere I see x, I'm putting in -4. And everywhere I see y, I'm going to put in -27. All right, so there's that equation. And you guessed it, we're going to do the exact same thing for the third point. Everywhere we see x, I'm going to put in 2. And everywhere I see y, I'm going to put in -3. Oops. And you might be wondering why I chose to flip my A to the back and my B to the back here instead of having A and B in the front like it was in the main equation. And it's just because we usually write numbers first and then variables second. Okay, so we've got our 3 equations done. And now we're going to go ahead and simplify this. I'm going to make a little more room on our screen. So I'm going to go ahead and we're going to start with our first equation, and we're just going to get rid of all the exponents and make sure our signs are correct. So we're going to have -1 squared is 1. 1 times a is a, plus -1 times b, which is -1, plus c, and that equals -6. For our second equation, -4 squared. So the negative is squared here, is 16 times a, 16a, minus 4b, plus c, equals -27. And you might notice I'm trying to be very neat here because that helps us keep our work nice and tidy in math. All right, so we have 4a plus 2b plus c equals negative 3. All right, so this is where things get a little more tricky because what we have is we have 3 equations and I can only really deal with 2 of them at a time. I am noticing that I also have c, positive c in each equation. So I am essentially going to eliminate c from 2 equations, and then I'm going to pick another 2 equations and eliminate c again so that I have 2 equations that only have 2 variables, because we can only solve for 2 variables when we have 2 equations. So I'm going to pick my top equation, and I'm actually going to run a negative through this top equation. So let's do this one. I'm going to run a negative 1 through this, and I'm going to write it down below. So I have negative a plus b minus c equals positive 6. So every term was multiplied by negative 1. Okay, and then because I manipulated the c value and I'm trying to eliminate that, because I'm going to use the elimination method here, I'm just going to rewrite my second equation as is. Now, is this the only way you can do this? Absolutely not. There's lots of right ways. This is the way I'm choosing to do it right now. Okay, so my goal was to eliminate c, so let's just check that I did that. Is negative c plus c 0? It is. That means it's gone. And now using the elimination method, I'm just going to combine the like terms. So I have negative a plus 16a, which is 15a. I have b minus 4b, which is negative 3b, equals 6 minus 27, or negative 27 plus 6, which is negative 21. Okay, what I'm noticing about all 3 of these terms is they are all divisible by 3. So I'm going to simplify this just a little bit more, and I'll explain why here in just a second, but just trust me here. So I'm going to have 15a divided by 3, which is 5a, negative 3b divided by 3, which is negative b, equals negative 21 divided by 3, which is 7. Ooh, not just 7, but negative 7. All right. Now, we get to do this exact same process again using a different set of 2 equations. What I am going to keep is I'm going to keep using this first equation because I already have a negative c, so I'm going to use these 2 this time. All right, so I'm going to use the one I already ran the negative through, so I'm going to use negative a plus b minus c equals 6. And then I am going to rewrite my green equation. And because I've already made c negative like in the last time, I don't need to do anything to the green equation. So what's nice about the way that I'm showing you how to do this is it decreases the amount of work you have to do. So let's make sure that we correctly eliminated c before we combine like terms. Negative c plus c is 0. Great. All right, now we have negative a plus 4a, which is 3a. We have b plus 2b, which is 3b, equals 6 minus 3, which is 3. So like the last equation, I'm noticing that each of these terms is divisible by 3. So I'm going to just clean this up a little bit and divide each term by 3, and that gives me a plus b equals 1. All right, so now we have 2 equations that just have a and b together. And what we are going to do is we are going to use the elimination method to eliminate one of the variables. So I'm going to write them as a system of equations again. So we have 5a minus b equals negative 7. And we have a plus b equals 1. So what's great about this particular equation is b, there's a positive b and a negative b, so this becomes a 0. So I have 5a plus 6a, 5a plus a, which is 6a, equals negative 7 plus 1, which is negative 6. When I solve for a by dividing by 6, I get a equals negative 1. Okay, so there's my a value. All right, now you guessed it, just like the elimination method, I'm now going to pick one of my equations to plug negative 1 in for a, and I'm actually going to pick my green equation right here because b is positive, and that's what I'm going to solve for. So I'm going to go ahead and do that over here. So everywhere I see a, I'm substituting negative 1. B stays the same because that's what I'm solving for. That equals 1. To solve for b, I'm going to add 1 to both sides. and b equals 2. So now we know a and we know b, and the only thing left that we need to solve for is c. So I'm going to come back up here, and I am looking for an equation that I can plug a and b into, and I'm going to choose this one because it's the simplest. So a minus b plus c equals -6. I'm going to scroll back down. Okay. So we have a minus b plus c equals -6. Let's just double check I wrote that right, because we wouldn't want to mess up on this stuff. That would take a lot of extra work. Everywhere I see a, I'm substituting -1. Everywhere I see b, I'm substituting 2. And then what that will let me do is solve for c. So I'm going to go ahead and in a, I'm going to substitute -1. I'm color coding these so you can see what I'm doing. Minus b, which is -2, plus c equals -6. All right, time to simplify. So we have -1 minus 2 is -3, plus c equals -6. To get c by itself, I'm going to add 3 to both sides. And I end up with c equals -3. So now we have all 3 of our values. We're so close to being done. So we started off with this equation, y equals ax squared plus bx plus c. And now to finalize this, all we substitute is -1 for a, 2 for b, and -3 for c. And we have our final equation ready to go. So remember, we need to keep y and x because that allows us to put everything in. So in math, every possible value within this parabola in. So when we have a -1 in math, we often don't write -1, we just write negative. So a is negative x squared, okay, times x squared, plus b was 2x, and c is -3. This is our equation. So I would recommend the next step is that you check that you actually did this right. So we had 3 points. We had -1, -6. We had -4, -27. And we had 2, -3. So I'm just going to do a little mental math to see if what I plugged in is correct. So I'm going to plug -1 in everywhere I see x, and I should get out -6. So -1 squared is 1, times a negative is -1, plus 2 times -1, which is -2. Maybe I should write this down so I remember. So I have -1 minus 2 minus 3. That gives me -6. So check this one is correct. If you wanted to write this down, you could do something like this. -4 squared plus 2 times -4 minus 3. So that gives me -16, right? Because negative times -4 times -4, which is +16. +16 times a negative is -16. Plus 2 times -4, which is -8, minus 3. This gives me -27. Check, that's correct. I'm going to do the last one in my head. I have 2 squared, which is 4, times a negative, which is -4, plus 2 times 2, which is 4. So -4 plus 4 is 0, minus 3. Minus 3 is what we're left with, and this is correct. So I know this equation that we found is the equation that passes through the 3 points we started with. And like I suspected, there's a negative there on our a value. And what that means is our parabola is in fact upside down. So if we were to come back here and we were to sketch the graph of this, I'm not quite sure what the vertex is, but it would look something like, oops, let's try that again. Oh no. It would look something like I don't know, like something like this, okay? Where it passes through the 3 points and it's upside down. I'm not quite sure how many roots or x-intercepts this has off the top of my head, but this is generally what this would look like. All right, that is how you write the equation of a quadratic function through 3 points. Thanks for joining me. Till next time, remember, you've got this.